Hey guys, this is Mr. Pinilla and we are going to see today the quotient rule for differentiation. So let's say first the rule says that if we have two functions f and g that are dividing and we want to find the derivative, the rule states that the derivative equals the denominator to the square, and at the denominator we have the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. So let's apply this to the example. Let's say we have the function y equals 4x to the square plus 2 over 3 minus x. The first step that we should do is to identify f and g, and of course here is clearly we'll see that this one is going to be our f because it's the numerator, and this one is going to be our g. So next step, once we are differentiated, we apply the rule. It says that at the denominator we have g to the square, so it's 3 minus x to the square, and the denominator we have f prime, and this is 4x to the square plus 2 prime times the denominator, that is 3 minus x, minus 4x to the square plus 2, which is f, times the derivative of the denominator, that is 3 minus x prime. Now we go and compute each of the derivatives. Individual derivative, the derivative of this one is 8x, the derivative of 2 is 0, so it's not necessary to write it, times 3 minus x, we do not touch the derivative, you do not compute the derivative of 3 minus x, minus 4x to the square plus 2 times the derivative of the denominator, that was 3 minus x, well, the derivative of 3 is 0, and the derivative of negative x is negative 1, divided by 3 minus x to the square. So now we continue with distributive property. 8 times 3 is 24, x minus 8 to the square, 8x times x is negative 8 to the square. Here is negative times negative can give you positive, so positive 4x to the square plus 2 over 3 minus x to the square. Now we add the terms with the same order, so we have positive 4x to the square and negative 8x to the square, that give us negative 4x to the square. Then we continue with positive 24x plus 2 over 3 minus x to the square, and that is the answer to our problem.